Welcome back, students. We were doing problem 1. We have this data table and mean and standard deviation are given, and we were doing hypothesis testing. These are the hypotheses. Null is about 75 given from the problem, and alternative is no, it exceeds 75. That's the alternative. Now, how do we actually test? We talked about critical value method and probability value method. Now let's talk about hybrid method. Hybrid method, just like critical value, you look for, just like probability value, you find out t-bar, and just like critical value method, you look for t-score for the critical value. And this is the initial picture you have, and then shading looks very much like those of critical value method, except that you're using t-scores only here. Instead of having same picture centered at 75 and then critical value here, in hybrid method, centered at 0 because we standardize, and this is t-score for the critical. Now, what is t-bar? T-bar is coming from x-bar, n minus center over SE, and that's end is x, center is mu 0, over SE, which is in this particular case 77.33 minus 75.0 over 5.037 over square root of 22. You can calculate, and we calculated them using Mathematica here, and this is our t-score for t-bar. And what's the t-score for the critical value? This time no bar anymore. T1 is left hand side, but we don't use that. T2 is right hand side, so let's use T2. And then that one is associated to 5% here and then 95% there, and you can look up from the table, from the T table here, T table, degree of freedom is 21, and 5% to the right hand side, 1.721, exactly the way we used critical value approach. Is it 1.721? Yes, 1.721, and that came from the table. What do we do now? Compare these two. Now, t measures roughly the distance from 0 because everything is now relabeled in terms of t. So t2 right here is 1.721. T bar is bigger than that, so it falls in the red region. And that's what these computations are all about. And this conclusion is all about. 2.17, the t-bar falls into the red region. If you like this method, you can use it. In order to use this method, you have to be really comfortable with transformation, graph transformation, and rescaling. Rescaled everything into t measure. This is not mu naught anymore, 0, and the distance is all measured in t. And if you understand that kind of graph transformation, then this method works very, very well. But if you do not understand all those details, then you can get lost here. So I would say this is very similar to solution 1, critical value method, except that it goes a little bit deeper in theory. Now solution 4 is something I do not really emphasize, but there's some theory behind it too, so let's talk about it. If you're not interested in solution 4, you can stop this playing right here. You look for confidence interval, one-sided confidence interval, and then see whether mu0 is in the confidence interval or not. Here's the initial picture. This time center is the observed mean of 77.33, just like the way you did in chapter 9 exercise set A. 5% here, 95% there, so you're looking for 5% lower confidence bound. What did I say? 5%? Excuse me. 95% lower confidence bound. That's your x1. And compare that x1 with mu0. Mu0 falls here too far away, then null loses and alternative wins. Mu0 falls here, then mu0 and x bar are pretty close, so null wins. So blue here, red there. And you can find out confidence interval or confidence bound using the same technique. N minus center over SE is your t-score. You're going to the left, so we need negative sign. And this value is 75.48 something. So the confidence interval begins from 75.5 all the way to positive infinity. And will mu0 fall into that one-sided confidence interval, which is represented in blue? The answer is no. 75 is too small. It doesn't fall into this confidence interval. It falls outside. So we reject null and accept alternative. That's how you can work out the confidence interval or one-sided confidence interval for hypothesis testing. Please be warned, this confidence interval method does not work for proportion problem. Otherwise you can use it, but still my favorite method remains solution 1, the critical value approach.